Greetings. In this video we'll be looking at trace table. At the end of this video you should be able to accurately trace an algorithm or program, accurately draw a trace table, and correctly define a snippet. If you're new to this channel, you should subscribe so you do not miss any new videos. Also, if this video was beneficial, please like and share. Thanks. So without further delay, let us begin. Now, what is a snippet? So the general definition is it is a small piece or brief extract of something larger, right? So in problem solving or programming, a snippet is a small portion of code which is important to the task at hand, right? So sometimes you might hear persons referring to snippet as fragment. So here I have a sample pseudocode which is requesting a name and age and then outputting the name and age with a message, right? And here on the right I have an example of a snippet, right? And this is basically a brief extract or small portion of the larger pseudocode which is on the left. So this is how a snippet would look, which would be a small portion of something, and this is an example of a larger whole which is a pseudocode, right? So just remember that snippet is a small portion or brief extract of something, and in the programming world it's a small portion of code or a fragment of code, right? So let's move on. Now, what is a trace table? Well, a trace table is a technique used to test an algorithm or pseudocode or program in order to make sure that no logical errors occur while calculations are being processed, right? The trace table simulates the flow of execution of an algorithm or program or pseudocode, right? This is done in a step-by-step manner, so just remember that. Values of variables are changed when an assignment statement is executed or an input statement is executed, so just remember that, right? So basically a trace table is used to track changes in an algorithm or pseudocode, right? To learn more about the different types of programming errors, please see my video that deals with this topic. Alright, cool. How do you trace a program? Well, that's a very good question. So let me show you exactly how to trace a program, right? So to trace a program, right, or algorithm or pseudocode, it is pretty straightforward. What you will do is to first identify your starting point, then move down your code or your pseudocode, right, or your algorithm line by line until you reach to the ending point, right? At each point, what you will do is interpret what the code is saying, do your analysis or calculations, then move to the next point. Okay, so let me show you the concept with an example. So here I have a sample program which is this here, right? And I am going to trace this program line by line, right? My starting point will be the line marked 1. So my starting point will be here and my ending point will be here, right? So if you're going to trace this program, what you'd basically do is go through the program line by line. So you'd go to line 1, you would look what it is saying, then you'd go to line 2, you'd look what it is saying, do your analysis, etc. You'd go to line 3, then you'd go to line 4, then you'd go to line 5, line 6, you'd go to line 7, and you do this until you reach the ending point, right? So that is how you basically trace a program, by going through it line by line and doing the necessary interpretation, calculations, etc. at each line, right? And once that is done, you move on to the next line, right? Alright, cool. So let us look at how to draw a trace table by doing a few examples. So what we're going to do here is do a trace table for 4 different examples, right? Very good practice. And the first example is asking us to draw a trace table to show what would be printed by the algorithm if the initial values are age equal 10 and name equal to Ryan, right? So on the left here, what we have is a snippet or a fragment of code, right? And the question is asking us to use this snippet or this small piece of code and draw a trace table, assuming that the initial value for age is 10 and the initial value for name is Ryan. So let's see how we would do this. So the first thing you do is draw a table, right? And the number of columns you have in the table will be dependent on the number of variables that are in your pseudocode or program that you want to trace, right? So in this case we have two variables. We have age, so let me show you. We have age and we have name, right? So hence we need one column for age and one column for name. We also need an extra column for the output in the program. So in this case we only have two variables, right, and the extra column which is needed for the output. So that is where you would put all the output in the program, right? So your table would look something like this, right? So we have age, which is one variable. We have name, which is another variable, so we'll put them as header in the table. And finally we have a extra column for output. So what you're going to do now is go through this snippet or fragment or code line by line and doing your necessary calculations and substitution at each line, right? So let's see how we do this. So we're going to start at line 1, and at line 1 it is an output statement, right? So in the output section of the table we're going to write what would be displayed, and we know that anything that comes after a print statement, right, in quotation, is output as is. So in a sense what will be outputted at line 1 is the phrase enter your age, and if you look in this table right here it will go here, right? Once we do that, we're then going to move to the next line, which is line 2. And if you remember the question, it says that we're supposed to assume that the initial value for age is 10. So it means that when we see at line 2 here, read age, we are assuming that the user will actually enter a value for age and the value will be 10, right? So hence in the table that we draw, or the trace table that we draw, in the second row, right, we're going to put the value for age, right? And if you realize that we're moving down row by row in the table, so each line is a row in the table. So line 1 is the first row in the table, line 2 in the pseudocode is the second row in the table, and as you guess, line 3 will be the third row in the table, right? Alright, so let's move on. So we're going to move to the third line, and the third line says that we're supposed to print enter your first name, and that is an output statement, and we know that anything that comes after the print keyword that is in quotation, we're going to write it back as is, right? So in the trace table under the output section in the third row, we're going to write enter your first name because that is what is in quotation after the print statement, right? So once we finish with the third line, we're going to move on to the next line. So we're at the next line, and the next line says read name, right? And the question said that we're supposed to assume that the initial value for name is Ryan. So now that we're at line 4 where it says read name, and we know that read is an input statement. So once you see read, you know that it is assuming that the user will enter something or enter a value. So in this case, when we have read name, right, then the value that the user will enter is Ryan. So hence under the name column, right, in the fourth line we write Ryan. Once you do that, you can move on to the next statement, right, or the next line. So we move down to the print age, and print age is an output statement. So in the trace table we will move over to the output column, right? So let me show you something quickly. So print age, which is at line 5, is an example of an output statement, and the keyword print is the keyword, or is a keyword that signifies output. Whatever comes after it is what will be printed, but in this case it's not the word age that will be printed, but rather the value of age, right? And the last value of age is 10 if you look right here, right, based on what is in the trace table. So when we reach down here and we say print age, it means under the output statement what we're going to do is substitute the value of age, which is 10. So we're just going to put 10 right here. Once we do that, we're going to move to the next line. So we move down to the 6th line, right? And it says print, and in quotation it says your name is, it close the quotation, then it has a comma, and then it has name, right? So this is what would be outputted right here, right? Because we know that what is in quotation after a print statement is written exactly as is. So it means that your name is will be written exactly as is, and the value of a name, because it is not in quotation, will be substituted, and the value of a name in this case is Ryan, so it will be substituted right here. So hence the output statement we will have your name is Ryan, right? And that is our first trace table. Now there is one last thing that I need to show you, and it is these little dash that I have been putting in the different cells. Now when you have a row and you put data in a particular cell, so like at this row, the first row or line 1, it links to the first statement in the pseudocode where I have print enter your age, and I place it right here, right? Now in the first line in the pseudocode there was nothing for name or age, so what you can do, you can leave it blank. So I could leave it blank, or you can put a dash underneath the name and the age cell to show that it is blank, right? So if you look at the second row, which links to the second line in the pseudocode where it says read age, now it would go, the value for age would be substituted and placed right here. So there would be no value for name or for the output. So what you can do is leave the name cell or the output cell blank, or you can put a dash just like I have here, right? So just remember that. So let's move on. Alright, so the second example, and the second example is asking us to draw a trace table assuming the initial values are a equal 2, so a equal 2 and b equal 3, and the second question says what will be printed, right? Now from the first example we know that when we're drawing a trace table for a code or pseudocode or algorithm, what we're going to do is first identify the number of variables that we want to trace in the code or pseudocode or algorithm given, right? So here this is the snippet that is given, right? And if you look in it, it basically has two variables. So we have a and we have a b. So it means then that we need two columns because we're going to check the changes for a and b. And it also has a output statement which is here at line 4, sorry. So it means then that we need a extra column that we will call output, and all the output in this snippet or fragment or piece of code will go into that section, the output section, right? So let's see how we do that. So first we draw our table, right, with 3 columns, 1, 2, 3 columns, and we place the variables that we want to check as headers in the table. So we want to check a, and so why we have a here. We want to check b, right, and so why we have b here, and there is a output statement in the snippet, and so why we have the third column which is called output. So what we're going to do now is go through this snippet or fragment or piece of code line by line and substituting values as we go down each step. So let's see how we do that. So we're at line 1, right, and line 1 says read a comma b. So it means that line 1 we're going to substitute the initial values that we got for a and b. So right here where it says read a, the initial value for a is 2 based on the question. So in the trace table under the a column in the first row we're going to write the value 2. There's a comma and then there is b, so read b. The initial value based on the question for b is 3, right? So in the first row, because both of them is in the first row, so in the first row under the B column, right, we're going to write 3 because we're substituting the value of B, right? So it's 3. Once we do that, we're going to move to the next step, which is the next row. So we move down to line 2, right? And line 2 says let A equal A plus 2, right? So it is an arithmetic statement. In pseudocode, our algorithm, you might see the equal sign being written like this, or you might see it being written like this. It's the same difference, just remember that. So at line 2, right, it says let A equal A plus 2. So what is the current value of A? The current value of A was 2, right? And we're adding 2 to that. So if the current value of A is 2, we could rewrite that as A equal 2, because the current value would be 2 here, right, plus 2, which would be this 2 here, right, which would be equal to 4. So hence in the second line, the value of A is 4. All right, there is no value for B and no value for the output, hence we just put a dash, or we could leave it blank. Once we do that, we're then going to move to the next line. So let's do that. So we move to line 3, and line 3 says let B equal B plus 3. What was the last value for B? The last value for B was 3, which is here, not true. So if we rewrite it as B equal, the last value for B was 3 plus this value here, which is 3, right, is equal to 6. So hence the new value for B is 6, hence we write it here. There is no value for A, and then there is no value for output, so we put a dash like we have here, or you could leave it blank. Once we do that, we're going to move to the next line. So let's do that. So we're at line 4, right? And line 4 says print A comma B. So it means that we're going to output the value of A and B in one line. So here we have print A. What is the value of A currently? The last value of A is 4 based on what is in the trace table, because we always use the last value that is in the trace table. So hence why in the output section for A, we're going to substitute the value of A, which is 4, and put it here. Then we give a space, and then it says print B. So we're now dealing with the B. What is the last value of B? Based on the trace table, the last value of B would be 6. So hence where it has print B here, we're going to substitute 6 for B. Hence we have 6 here. So what will be printed? 4, 6, right? So this is a trace table, which is question number 1, right? And question number 2 says what will be printed. What will be printed is 4, 6. Alright, so here is example 3, and example 3 is asking us what would be printed by the algorithm if the initial values are A equal 2. So the initial value that we're working with for this snippet is 2. So it means that anywhere the initial value, anywhere the first time that we see A, we're going to substitute it with the value 2, right? Now we should remember that to draw a trace table for this snippet, you're going to look through your snippet, right? And you're going to identify the number of variables in the snippet, right? In this case, we have 2 variables. We have A and we have count, which is 2, right? And if there were other variables but we weren't tracking them, then we wouldn't put them in the trace table, right? So in this case, there are 2 variables and we're going to track the changes of those 2 variables. So hence we're going to need 2 columns, one for A and one for count, right? Now if you look in the snippet as well, there are output statement. Here's one and here's another one. So it means that we will also need a extra column which will be called output, where we will put all the output in the snippet, right? So let's see how we do that. All right, so we will draw a table, right, something looking like this, and we will label the headers for the table with the name of the variables that we want to track. So in this case we want to track A, right, and we want to track count. So in the table, the first header will be A, and the second header will be count, and the third header will be output, because there are print statement in this snippet. So once you do that, what you're going to do now is go through your snippet, or go through this snippet line by line, analyzing each line, doing calculations and substitutions at each line, and once that is done, move on to the next line. So let us see how this is done. So we're at line 1, right, and the question says that we should assume, right, that the initial value for A is 2. So here at line 1 we have read A, so it means that we're going to substitute the value for A with 2. Hence why in the trace table over here, under the A column, we write the value 2 here. In the first line there is no value for count, so we just put a dash, right, or we could leave it blank. And there is no output in the first line, so we put a dash or leave it blank, right? So once we do that, we're then going to move to the next row or the next line. So we move down to the next line, right, and the next line says for count equal 1 to 5 do. So it means that this for loop is going to increment from 1 to 5, or in other words, it's going to count from 1 to 5, or in other words, it's going to move up from 1 to 5, right? So the first value for count will be the first value that is assigned to it, which is 1, right? So under the column that has count as a header, in the second row we're going to write the value 1, which is this value here, right? Good. There is no value for A, so we put a dash or leave it blank, and there is no value for output, so we put a dash or we could leave it blank. Once we do that, we're then going to move to the next line, right? So we'll move down to the next line, and the next line says that A equal A plus count. What was the last value of A? The last value of A was 2, so we could rewrite it as A equal, the last value of A was 2, right, plus count. What is the last value of count? The last value of count is 1, which is right here, so plus 1, and this would be equal to 3, hence why we have 3 here underneath the A column, right? Cool. So once you do that, so now that we have the third row, what we're going to do, we're going to move one more step. So the program is then going to move down to the next line, which is the end for, right? But this for loop is going to move from 1 to 5, and just now it is the first time that we actually went through the for loop, because if you look here, count is 1, right? And so we're going to do this until we reach 5. So it means that we're going to go back to the start of the for loop, right, and the value is going to automatically increment. It is going to automatically go to the next value, and the next value would be 2. So count would now be equal to 2, because we start off with 1, right, but we're going up to 5, right? So now we're at 2, so the value for count is 2. So if you look here, the value for count is now 2. There is no value for A, so put a blank or a dash. There is no value for output, so we put a dash, right? Then we're going to move to the next line. So we move down to the next line, and it says A equal A plus count, right? Now what is the last value for A, right? The last value for A was 3, which is this, and the last value for count is this, right? So if we have A equal A plus count, it means that we're going to substitute the value for A here, which was 3, and we're going to substitute the value of a count, which is 2, so we would get 5. So hence why we have 5 here, right? And there is no value of a count, so we put a dash. No value of a output, so we put a dash. And we're then going to move to the next line, which this case is the end for, right? So let's see. Then because this is a for loop, right, and we're moving from 1 to 5, right, and we're just at step 2, it means that we need to go back to the beginning of the for loop. So we're going to go up to the start of the for loop again, and the last value of a count was 2, so it means that the for loop will automatically increment count from 2 to 3. In other words, the for loop will count up from 2 to 3 automatically. So the value of count right here is now 3, which is here, right? There is no value for a, so we'll put a dash. There is no value for output, so we'll put a dash, right? Once we do that, we're then going to move to the next line, and the next line will be this one, right? And it is saying a equal a plus count. Now let me show you how you do that. You would have a equal a. What is the last value of a? The last value of a is 5, so you would substitute the value of 5 here, plus count. What is the last value of count? The last value of count is 3, so you'd put 3 there, right, which would be 8. So if you move to the next line, it means a is now 8. There is no value for count, so you put a dash. No value for output, so you put a dash. Then we're going to move to the next line, right? So let's see how we do that. So we go to the end for, right? We're then going to move up to the start of the for loop again, right? And it's going to automatically go up to 4, or the correct word, it's going to increment to 4, because the last value was 3. Hence why the value for count here is 4. Then we're going to move to the next line where it says a equal a plus count, right? The last value for a was 8, right? And the last value for count was 4. So if you have a equal a plus count, it would be a equal 8 plus 4, which would be 12, right? So it means that the current value for a is 12. There is no value for count, so we'll put a dash. No value for output, so we'll put a dash, and we move on to the next line, right? So we move down to the end for, right, and we'll move back to the beginning of the for loop. This time it will automatically increment the value of count from 4 to 5. So count is now 5, right? Hence underneath the count column we have the value of 5, right? So we are in this line here. There is no value for a in this line here, hence why we put a dash here. There is no value for output, hence why we put a dash here, right? Then we're going to move to the next line, right? So we move down to the next line, right, and it says a equal a plus count. The last value for a was 12, right, and the last value for count was 5, right? So if we have a equal a plus count, it means that the a here will be 12, right, plus the value for count, the last one is 5, so we put the 5 here, and we would say a equal 12 plus 5, which is 17. Hence why we have the value 17 here, right? So we are at this line. So there is no value for count, so we put a dash here. There is no value for output, so we'll put a dash here, and we basically move on to the next row. So move down to the end for, right? Now this is important. We did say that the for loop is going to move from 1 to 5, right? And if you look here, it started at 1 and it's actually at 5 now. So it means that the for loop will not run anymore. So what is in the body of the for loop will not be executed anymore. So in programming world, what we will say is that we will now break out of the for loop. So look how it goes. So we're currently at the end for, which is right here, right? The program is then going to go back to the for loop, the beginning of the for loop, right? It is going to realize that count is now 5 because here the condition here we're saying that we're moving from 1 to 5, and if you look here the value of a count is 5. So the for loop is going to realize that, so it's not going to go in the body here anymore, rather it's going to jump to the end of the for loop, which is down here. So it skip out this altogether, right? So it jump right down to the end for here. Then it is going to go to the next statement, which is the print value of a is a, right? And this is what will be outputted in the next row, right? Remember, print is an output statement, a keyword for output. Whatever comes after print, which is in quotation, will be written exactly as is. So in quotation here we have value of a is, so we will write it back exactly as is. We have the letter a here, which is a variable, which is not in quotation. So what it means is that we're going to substitute the value of a right here. And what is the last value of a in the trace table? The last value of a is 17, right? So we're going to substitute it right here. So it means that the output based on this line will be this that we have down here. Value of a is 17, right? All right, good. Then the program is going to go to the next line after that, which is this line, and it says print count, right? This line. So what is the last value of count? The last value of count based on the trace table is 5. Not true. And anything that comes after the print statement that is not in quotation is a variable, hence we're going to substitute the last value of count where we see count here. So hence the output from this statement will be written as this, which is 5, right? And that is how you basically do example 3. So let us look at the last example. Alright, so example 4, right? And example 4 is asking us to draw a trace table for the following snippet. Assume the values will be entered for y are 3, 2, 4, 0, 5, 6. So what this question is asking us to do is basically to look at the snippet above, which is this, and we're supposed to draw a trace table for it, and assume that anywhere we see an input for y, we're going to use these values, right? Which is 3, 2, 4, 0, 5, and 6. So let's see how this will go. Alright, so if you look at the snippet, right, how many variables do we have? We have a q here, and we have a y. We have q and y. So it means that we have two variables. We want to track the process or trace those two variables in the program. Hence, we're going to draw a table. We're going to have one column for y because we want to track y, right? We're going to have another column for q because we want to track the changes for q, right? And there is a output statement. See it? How do I know that it's an output statement? Because it has the keyword print, right? And once you see the keyword print, display, output, show, right, write, you know that those are keywords for output, right? So hence we need another column which we will name output, and this is where all the output in the snippet or pseudocode or algorithm or code will go, right? So let us see how we would do this one. So now that we have our table, the first thing that we're going to do is go through this snippet, right? This snippet line by line and analyzing each line, substituting values as necessary, right? And once we do that, move to the next line. So let's begin. So the first line that we're going to go to is line, which is this line here, right? And it says q equal 0. So in the trace table, the first row, we're going to go underneath the q column, right? And we're going to write the value 0. Then once we do that, we're going to move to the next line, right? And the next line is this line here, and it says read y. Based on the question that is given down here, right, it says that we should enter these values for y, right? So it means that here where we have read y, the first value that we will enter is 3, right, for here. So let's see how we do that. So we're going to move down to the next statement, which is read y, right, and the value that we will enter is 3. So it means that under the y column, right, we're going to enter 3, or we're going to write 3. In this row here, or this line here, right, there is no value for q, so we put a dash. There is no value for output, so we put a dash. Once we do that, we're going to move to the next line, right? So we move to the next line, and the next line says, while y is not equal to 0, we're gonna do this in the body here. How do I know that this is where I'm supposed to stop? Because this is the body of the while loop, right? The body of the while loop is between the do here and the end while here. So it means that we're going to repeat whatever is from here to here until y is not equal to 0. So as soon as y is equal to 0, we're going to break out of this while loop and continue down here, right? So let's continue our trace table. So we're at here, so we're going to move to the next line, and the next line says q equal to q plus y, right? What was the last value of q? The last value of q was 0. And what was the last value of y? The last value of y was 3. So if we have q equal q plus y, it would be q equal 0 plus 3, which is 3. Hence why underneath q column right here we have the value of 3. There is no value for y, so we put a dash, and there is no value for output, so we put a dash, right? Once we do that, we're going to move to the next line, or the next statement, which is this one, and it says that we're supposed to read y. Now the next value that we're going to enter for y is 2 based on the question, right? So hence underneath the y column we put the value 2, right? There is no value for q in this line, so we put a dash. There is no output in this line, so we put a dash here as well, right? Then we're going to move to the next row, right? So let's see how we do that. So we'll move to the next row, which is the end while, and it's going to move back to the start or the beginning of the while loop. Why? Because y is not equal to 0, right? The value of y is actually 2 based on the last input here, not true. So it's going to move down one more time, right? So it's at this line now, right? And it's going to say q equal q plus y. What was the last value of q? The last value of q was 3. And what was the last value of y? The last value of y that we entered was 2, right? So q plus y is basically 5 in this case, right? So q, which is 3 here, plus the 2 here would equal to 5. Hence underneath the q column, right here, we put the value of 5. In this line right here, there is no value for y, so we'll put a dash. There is no value for output, or there is no output, so we'll put a dash, right? And we basically move to the next line. All right, so we're going to move to the next line, right? And it says read y. So the next value that we're going to enter for y is 4, right here. So we are in this line. The value that we're going to enter is 4. Hence why underneath the y column, right, we have the value 4 right here. So there is no value for q in this line, so we put a dash. There is no value for output, so we put a dash, right? And then we're going to move to the next line. So we're going to move down to the end while, and it's going to jump back to the start of the while loop, right? What's the current value of the y here? Because this is the condition that we're using to control the while loop, or this is the condition that we're using to determine how long the while loop will run. And based on the condition here, this while loop will run until y is equal to 0. So it says that while y is not equal to 0, we're supposed to do whatever is in the body of the while loop. So as soon as y is equal to 0, we will break out of this while loop. So what is the current value of y? Right, the current value of y is 4 based on the trace table. Not true. So it means that we're not going to break out of this while loop. We're going to continue to execute this while loop. So we're going to move to the next row or next statement in this snippet. So we're going to move down, and it says q equal to q plus y. Right, what's the last value of q? The last value of q is 5, right, and the last value of y is 4, right? So q plus y is 5 plus 4, which would be 9, right? So q, so let me see if I can write this properly. Q would be equal to the last value of q, which is based on the trace table is 5, plus the last value of y based on the trace table is 4. So put a 4 here. So q equal 5 plus 4, which would be 9, right? Hence why under the q column right here we have q as being 9. In this row here there is no value for y, so put a dash, and there is no value for output, or there is no output, so put a dash, right? Once we do that, we're going to move to the next statement or the next row or the next line, right? So we move down, right, and we read y, and the value that we're going to enter for y is 0, because that's where we are in the list, right? Hence why under the y column I have 0 here for this line here, right? There is no value for q in this line here, so I put a dash, right? There is no output statement in this line here, so I put a dash, or I could leave it blank if I want, right? Now based on how the while loop work, it's going to jump back to the beginning or the start of the while loop. So it's going to go down to the end while, right, and then it's going to jump to the beginning. Then it's going to test the condition again, which is this. So this is an example of a condition. Y is not equal to 0 is an example of a condition. Another example of a condition is y is less than 2. This is an example of a condition. But to learn more about conditional statements and condition, please see my video that deals with those. So let me remove this from the screen so we can see what's going on. Alright, so this is a condition here, and we are now at this statement. The last value for y was 0, right? So now that we're here, the condition is going to be tested again, and it's going to say while y is not equal to 0, it's going to do whatever is between here. However, the last value that was entered for y is actually 0. So it means that we're going to break out of this while loop now, because the condition is now true, right? So look what is going to happen. So we're here, the last value for y is 0, so the while loop will go to the end of the while loop. It will skip everything that is in the body of the while loop, right? It will then go to the next statement after the end while, right? So it will go to right here, right, and it will say print q. Now the last value for q was 9, right? So hence when we have print q, it will output the value 9. So 9 will be printed. Alright guys, so I hope you understand how to do a trace table, and you can always shoot me an email or comment on the video if you need clarification on a particular area, and I will try my best to answer it. Alright, thanks.